Alright, now we're back. We made the top section. It's going to receive this section. So I'm going to turn this diameter down to this diameter there, which happens to be 40 millimeters, and it will take off about 30 mil deep. This is deeper than that, but it's going to hit on the shoulder that's going to be there, and so the depth of this is irrelevant. And then we'll also, once we've turn that spigot down, we will then insert a groove that when we do this bolt, handle, locating, lock, whatever you want to call it, I'll machine the end of that down to about 10 millimeters because this thread is M16 on this. So I'll machine the end of that down to, I don't know, maybe, I said 10 millimeters, but the groove will be 10 millimeters wide, but I'll machine that down to maybe 9 or 8, and that will allow for any mushrooming, so it won't be tight in the groove, basically. So let's get started. I've already cut this to length. I'll probably trim some more off of that. Alright, I'm going to take some more off of this because it's a little bit too long than I want, and then we'll come back. Alright, this is where we're at. I actually forgot to start recording, so I've already started it. This is to length. It was oversized because this is a really thick bit of steel, and I don't have a bandsaw, unfortunately, and every time I use my cut-off friction saw, it overheats the metal and the blade wobbles around everywhere, so I always cut everything oversized. But I went a little bit too far on this, and I trimmed down as much as I could to even it up to 105 mil. I only needed it at 100, so what I've done to compensate that, rather than take off all this material by facing it, I've got an extra depth in the spigot receiver in here. I've got nearly 40 mil here, mainly just to take out a bit of weight when I was drilling it, and I only need, it was supposed to be 30. So what we've done here is I've taken an extra 5 mil from that, and that will reduce the overall length, so the pedestal height will be what I initially measured it, and I still won't be bottoming out on that because there's nearly an extra 5 millimeters in there. So all good on that respect. So I'm just turning this diameter down to fit into there, and yeah, that's a diameter of 40 millimeters, so that'll fit nicely in there. It doesn't have to be a precision sliding fit, but that is slightly oversized by 0.2, so if I aim for 40 mil or just a smidgen over that, and I can test fit it until it slides nicely in there, because I do want it to rotate quite easily in there, and then we can work on the groove. Then we'll flip it over and we'll drill, we'll turn the other side down similar to what we've got here, to fit the pipe that it's going to go into. And that's where we are now. I mean, this is a lot of machining. I won't show all of it because I think I'm at 58 millimeters now, and I've got quite a bit of turning to get that down to 40 millimeters. I'll show a bit of it, and then I'll cut that out and get you to the finished diameter, or within the last cut of the finished diameter. So then we'll test fit onto this piece, and then I'll reposition the camera and we'll do the cutting of the groove that we're going to put in there. Okay, let's get going. Okay, we're back and we're almost to size. We're at 40.3. Alright, so take off another 0.2 off that. There we go. And remember, the mating piece was 0.2 oversized, I'm pretty sure. 0.1 or 0.2 oversized, so this may even fit on after this cut. Stop that. I'll just measure that. I always wipe it of the coolant before I measure it. Just gives you a lot more accurate measurement because a film from the coolant will actually, not that this is that accurate, but the film can actually influence a little bit, especially if there's a bit of fine chips in there or anything. Well, that's just under 40.1. Let's see if we can get that to focus. There we go, just under 40.1. So we'll see if this fits on there. It's got a bit of a shoulder, but so it's going on, but it is a tight fit. It's mainly because of the edge on that shoulder. I think if I get rid of that edge, probably go on a lot easier. And if I give it a bit of a polish with some emery, it'll probably go a bit better, but just give it a try. That might have done the I know it's tight, but once you get it on, it may, because it does feel loose, it's probably just a few high spots because they were very close. You may have a slight taper on it too. Very slight taper. It's going on right there. I might just get some emery and just give that a bit of a going over with the emery. Get through that tight spot. Don't take too much of it. Wipe. We could be getting hung up on the whole lip for the thread there. I don't know if you can see in there, but see the whole So I've cross drilled through the outside there. I think it's just got a bit of a high spot because it definitely feels loose enough. I don't want to keep taking more off there and it becomes really far too loose. I think it's just got to work this high spot. Maybe give it a bit of a file. Just give it one more try. So that's definitely going on a little bit further than it was before. So whatever I'm doing, it's working. I think I just have to work that high spot back a bit further, knock it down a bit, and she's going to slide on nicely. So I'll keep on that, and then I'll come back once I've hit the mark. Alright, now I tried filing it and emerying it, and then that didn't seem to work, so it must have been a bigger bird than I thought. So in the end, and it probably looks worse than it really is, I got my Dremel out and I just ran, it's got like an emery paper on a rubber drum, and I just ran around the edge of that, and like I said, it looks worse than it is. When you feel your finger in there, you cannot feel a step or anything. And now when we go to fit it, I might bring you around on this side. Test fit. It's as you can see, it fits on quite. There's no wobble, so we get a nice, easy spin. So it's probably could use a little bit more, I'd say, but I can't see it marking this. So it's probably just a bit of grinding dust that needs cleaning. Now, like I said, it is quite a. I don't feel any. Yeah, I may just go over that with a bit of emery, just to clean up any tool marks on it again. Still around. Give it a bit of polish. This is a used bit, so I'm basically just going to give it a bit of a polish up. Remove some little high spots. And it should go on nicely. Might get off the diameter maybe 0.01, 0.02. What I'm getting. Just a bit of a polish. Fits quite smoothly, and we'll set now. And it's, you're feeling the suction of the air getting trapped in there now because it is a nice fit, but as you can see, that rotates nice and freely. If we put a little bit of lubrication in there while assembly, we will be well and truly good. That fits nicely. That's what I'm looking for. I don't want a loose fit, not a tight, but it spins so easily, and that's all it's going to do. It's going to go, and we're going to have a groove in there anyway for where we lock it. It'll lock in the bottom of that groove. stop it spinning. That's great. Take that off. Now we can spin it around and we'll drill the other side. I probably should have drilled it before I turn this diameter. I don't think that's small enough to fit in the hole. May fit inside the chuck. So yeah, I can grab it on the outside of here and then bore the hole in the other side to, oh sorry, I don't have to bore the hole, just got to turn this down to the internal dimension of the pipe, about 30mm in, so it fits in there. So hopefully I can grab it on the outside and that will fit in the jaw inside the chuck, so I won't mar that up. Yeah, in hindsight probably should have done that first, because this needs to be rotated, and because it's such a nice fit, I don't really want to mar it up, but we should be right to do that. Okay, so we'll set you up in there. Let's see if we can spin that around. And we are in luck. It does fit in there. I might take that just going to take this edge off just with a file. It's not sharp. So grab a little bit of emery and just give it a quick that's it, nice and smooth now. Flip it around. So it sits front of the chuck there. That's going to get a bit of a clean up anyway. To turn this down, I only need about 30mm. I'll make sure I've got enough room there. Yep, I've got 40, so I'm going to take 30mm, turn that down to 56mm. That's been my little drawing, and that should fit inside here nicely. And then we'll do the same thing as we did on the other one. We'll fit that inside here. We aim for a tight fit, but last time we were at a nice sort of tight sliding fit. So we drilled a hole through here and put a grub screw in there and threaded it into there to stop it rotating. We may just do the same thing again, because this is not, as you can see, the pipe, it's not round, and I didn't want to take too much off the wall thickness because it's not a lot there in the first place. So I think the safer bet is we'll make a nice, we'll go for a friction fit, a slight friction fit, but I'm not overly concerned if it just slides in there, because we're going to do a drill it and put a grub screw in there anyway. Okay, and we'll just get set up for that now. This has been turned, but we'll see how true it runs. It's not bad. Concentric system doesn't really bother me because this thing doesn't rotate, so it's not going to vibrate, and it won't matter if this end isn't concentric to the other end. It's not a big deal, and that's going to sit in the bottom of that pipe, so what's there is good enough. We'll just take her in now, set up our DRO. So the measurements aren't critical on this. Light touch, 0 to Z. Bring this out and we'll go in and just touch there. We're not marking it yet. Just put a little score line there and I'll zero the X. Right, so now we will take a very light cut. Now we can measure that and set DRO to the baseline. So we've got, okay, 61.9 exactly. 61.9. So we go over the DRO. I'll show you what I do on the DRO. We hit the X key and we'll key in 60. Turn 0.9. Okay, but because I'm taking away, I have to make it negative, otherwise it'll add. So as I'm going in with the cross slide, that dimension will go down and tell me the size of the OD of the material I'm machining, rather than adding to it and I have to subtract what I've added, you know. So this will go down. So this theoretically, and it doesn't always work, I don't trust it 100% because I have this lathe has a lot of backlash and all that sort of thing, and even though the backlash doesn't affect this, there's a bit of flex and everything, so you never quite get it. It's usually within 0.1 sort of thing, so when I get close I go off my measurements rather than that. Sometimes it's really spot on, sometimes it's not, so I just get careful when I'm close. That's how I gauge where I am. Okay, so yeah, I'll set you back up and we'll continue on. Right, now I've machined that down. I didn't want to bore you with machining. It's the same as the other one and it's a pretty simple operation. I've machined it down. I went down to 56.5 and then I've just been taking small cuts and trying it with the mating part, because as you might remember, I sort of want this to be a press fit, but I want to be able to put it on by hand. I could tap it in there, but at the moment if I press it on, it'll be, I don't want to have to pull it off again, and I still need to machine the other side down to fit inside this part, and I won't be able to fit that on the lathe. So I'm not sure if you can see the marks from where it went in. Let's see, there it is there. So I wiggled it on to about there. You can see the contact mark there, there, and on the other side. Anyway, we'll flip this around and I'll have to show you bits and pieces as I've machined it, and step by step. Might just take this little bit of an edge off there while I've got it on there. A little bit of a sharp edge on the edge there. Just knock that off before I flip it around, and yeah, I'll come back once I've began machining the other side. Okay, sorry, I said not quite what I was thinking before. When I flip this around, I meant I need to turn this body down to match the diameter of here, because I'd already machined that previously. So basically what I want to do is now machine this body to match this body. So I just put a parallel strip in here and put that up hard against it, just nip that down. Hopefully I'm not biting in it too much, but like I said, that is a non-functional surface. Once I push that in to the bit of pipe, you'll never see it again, and the pipe's pretty soft, so it's not going to affect it. So yeah, just for aesthetics, I want this to be the same diameter. So I've measured this at 60.2, I think it was, and this is at 63 more or less now. So I've just got to take a mil off that to get to match that. And as you can see, that sits on there nicely. Once, what I do have to do is make the groove on that. So I'm not going to show up, I'll just machine that, and then I'll just show you when I set up for the groove in there, which I'll actually probably grip that here, or just push that all the way into there so I don't get it as close. Less overhang as much as possible. I may even drill a center there just for a bit of center support, because yeah, the grooving tool puts a bit of pressure on there. We'll see how we go. Probably put a center, best idea, give it a bit of support. Alright, see you soon. Okay, here we are, and I've just machined that down to match that diameter, so it just sort of continues on, and it should be good. Alright, give it a little bit of a polish up, because I plan on using like a gun blue on this just to protect it from rusting. Yeah, it's not quite gun blue, it's I'll have to get the name of it. I can't quite remember the name of the thing, but it's yeah, just a basic dip-in chemical. You've got to clean it up, and I'll run you through the process and show you it too, as it sort of leaves a finish like that, just to protect it, so it doesn't rust. And I'll show you that process when we get to that as well. Okay, so now I'm going to grab this on here, and we're going to set up to machine the groove. Okay, because when I grabbed it in the 3-jaw, I couldn't really get that back to concentric. It was always wobbling around, because it doesn't matter if that's not concentric, but when I do the groove, I really need the groove concentric. So I've put the 4-jaw chuck on, and I've clocked that in to within, let's have a look. Well, I'd say it was within 0.01, more or less. Anyway, it's close enough. 0.01, well, hold it. That's close enough anyway. Yeah, within 0.02, maybe 0.03 would be close enough for what I'm doing here. It doesn't need to be smack on, even though that is pretty good. I doubt you get that much better unless you really spend a lot of time clocking that up. And for what I need, that is really good enough. So now I'll set up. I also put some little aluminium, I call them my soft jaws, in there, just so I don't damage that. Biting into it, because there's a lot of bit of moving around, pushing it one way or another. You'd mark it all up if you didn't have them. And yeah, now we can set up for that groove. Okay, I'll bring you back once that's ready. Okay, I've got that set up in there as we had before. I've installed my grooving tool, and the width of that tool is 2.5 mil. So what I did was I know this is not critical, and that's not perfectly parallel to each. It's just ground to a sharp point, so it'll have some sort of taper on it. As you can see, I can see it in the camera now. It's got a taper on it, and it's not flat on the bottom, and it doesn't need to be. Okay, so yeah, I know that, I can see that. What I did was, as I touched on the side here, because this is not important, the dimensions, it doesn't have to be parallel, it just needs a groove big enough that when the locking screw comes down, it hits the groove, bottom of the groove, and doesn't mar up this surface here. Okay, so that's all it needs to do, this groove. So what I've done was, and look, if you need it accurate, you'd follow this same procedure, only your tool would need to be accurately and parallel, obviously. Okay, having a tapered side doesn't really bother me at all. Okay, so what I did was, and you could use this with the precision ground parting tool, and the process would be the same. I came in, I touched on there, okay, very lightly. If you push on too hard, you'll flex the tool. If it's a thin tool, mine's pretty thick, so I didn't have to worry about it. And I just lightly touched the side here, and then using my DRO, I zeroed the Z, and then I went in half the width of the tool, and that put me the center of my tool, which would be, you know, somewhere around there, on that edge, theoretically, I know. Then I zeroed it again, zeroed the Z dimension again, and then I wound out in the Z plane 15 millimeters. So theoretically, the center of my tool is now 15 millimeters off that face. And to confirm I'm in the correct position, or somewhere in the ballpark, I now fit that hard up against that, and as we can see, I'll wind it in, you know, we're in the ballpark. That's pretty much dead center. Okay, and lock the carriage, and that's on 15. So we're pretty good. So now what I'll do is I'll go in and I'll machine that. I don't need a massive depth. I might try and get 2 or 3 mil deep, should be plenty. That should be ample. And then I'll come out and I'll move over this side and that side until I think I want a gap of about 10 millimeters, and then I'll turn the locking screw down to about 8 millimeters to give me a bit of clearance for mushrooming on each side, and that should be all it needs. Okay, I won't show it. I'll come back, I'll show you when I do the groove. Like I said, my tripod's a little broken at the moment, that is in need of repair, so yeah, I'll come back, I'll show you the groove I do there, and then I'll show you when I make the groove bigger. Yeah, just keep coming back and showing you after I've completed each machining section, and then yeah, it shouldn't take too long, and we'll do that. Okay, back soon. Okay, we've cut our groove now. It's 10 millimeters wide and it's 15 millimeters out from this shoulder to the center, the same as this hole, and it fits on there. And I don't know if you can see it, but you can see an even edge on this side and that side, which should be about equal to about 2.5 mil on each side. 2.5, 10 mil, yeah, 2.5 mil. And we're going to make the little locking lever, turn that down to about 8 mil, which should give us ample clearance on both sides. And that way, as I've said probably many times before, when it clamps down onto this surface, when I've loosened it, when I turn it, it won't mar up and bind on this surface, which is going to be swiveling. You know, if I burr this up from a clamping and onto it, then when it tries to swivel, it's going to dig into the mating surface it's trying to rotate on. So by creating this groove, I avoid any of that, and shouldn't have any problems with it binding up. Well, that's that done. All that's left to be now is to mate the other end into the pipe, and I won't be able to do this one-handed because it's fairly tight, because there's a lot of pressure on here. I didn't want it going out around, because I clocked it up to about 0.01 and a half with the oil indicator, and I didn't want it moving, so it's done it quite. So I'll have to loosen it off, and then I'll bring you back and we'll fit it into the pipe, and then all that's left is to drill the hole in the end of the pipe, and we're also going to make the handle which will lock into that groove. Right, so I'll get that out and then I'll bring you back. Okay, there it is, the finished profile, I suppose, and we're going to now tap it into there, and I'll set you up. All right, let's get a little mallet, and hopefully just tap that nicely in there. Now, that went in quite easily. It was more just the alignment that was struggling with it. And that's sort of what I was looking for on the other fit, but I was a little bit loose. I achieved it with this one. There you go. Practice makes perfect, I suppose. So now I'll put this in the mill vise, and we'll drill the hole, to drill and tap the hole to lock that into there, even though that's, well, it probably doesn't need it, but for the sake of drilling one hole and it'll never move, we'll do it. So let's drill and tap that now. So I'll set that up in the mill. Actually, I don't even think I'll show that because we did it in the other one. I may just go onto the handle. We'll see what happens. I'm about to call it quits for today. So we'll come back next time and get into that part. See you soon. Okay, this is what will become the handle, which will be doing the locking to stop the whole pedestal from rotating when I don't want it to. So this is 16 mil, and I've turned that down to 8 millimeters to fit into the groove on the mating piece, which is in the vise ready to be drilled to there, so that it'll fit into this groove to lock onto that surface there. Now, as you might have noticed, there's some grooves in the top here. I basically just took the hacksaw and I went 3 cuts, 1, 2 and 3 in this direction, and then I did 2 cuts in that direction. And the reason I did that is to give it a bit of bite, because if it was just flat it would really just be very easy to turn. But when this dies in, it's going to make a bite and it's going to dig into the mating material. And even though it's pretty soft, I mean, I shouldn't need to tighten it up that hard. And with this added bit in here, if I can get the focus, it will give it some room to bite into that material to stop it rotating, and I won't have to do it up too tight. We'll see how it goes. Should give it a bit of bite to grab onto it. Alright, I just thought I'd show you that. I haven't done anything to the handle, it's long enough to get plenty on there. I'm waiting on a die. I don't have, I cut the thread on the mating part where this screws into as M16 by 2, but I don't have a die M16, so I'm just waiting for that to turn up before I cut that. And then I'll do the bending once I know the rotation of when it actually touches. So yeah, there we go. We'll come back to that once the die turns up. Bye for now. Okay, as you saw before, this is locked in the vise, and because I hadn't done another operation between this and the last one that I drilled in there, I'm still, because it's the same diameter, well, the pipe is anyway, I'm still on the center line for that, so there's no need to centerfine this edge and that edge and half it again. But I do need to know the distance from here to there, which is not really important, but for the sake of getting it within reasonable range of the other one, I've edge found this end, which is in there, and I've just compensated for the diameter of the edge finder, which is 5mm. That's 5mm, and you notice that's 2.5mm past the 0, which I zeroed it on there when it flicked out, and I've gone in the radius of that. So now the center of the spindle is directly on the edge there, which is the new 0, and that will be my 0 there. 0. Okay, so now I will just measure the distance I need to there plus 15mm, should get me directly over the hole of where the other one is, and that'll be that. Okay, well, I've got to change this cutter and I'll get it over there. I mean, you've seen this before, but so I'll just cut in and I'll show it center drilled, and yeah, I think I don't need to keep showing that because you saw it on the other one. And I'll bring you back when I'm ready to, once I've tapped it, I'll screw it in, and yeah, I'll just show you the clips of each finish, as you've seen it all before. Okay, bye bye. Alright, as you can see, we've center drilled it, and it is smack on center, ready to be drilled and tapped. Now I drilled this, tapped this, the other one M8. I'll do the same with this, and so I will be drilling it. Let's have a quick look. Reference. That's not it. I keep a reference chart here. Oh, here it is. You can see it there. So let's go, there's a metric. We will go down to the diameter, which is 8mm. This is ISO metric course threads. You want 8mm, so we want a tapping drill of 6.8. Now I don't have 6.8, I've got a 6.5mm is my standard drill. So what we do is then, to get it a bit closer, or to see if we can get it closer, I go to the first page of this, which it has drill sizes and decimal equivalents. So this has a metric of, I want 6.5, which is right there, 6.8, which is there. Now we've got an imperial equivalent here of 17/64, and that is a little bigger than 6.5, but a tart smaller, and you can see the decimal difference there, which is 0.02 thou. So it's 20 thou difference between that and that, which is a lot less than the difference between 6.5. Not that it matters, but I tend to do this because I like to get it as close to what the tapping drill size is. So I need a 17/64, and I know I have one of them because I used it on the other one, and there it is, 17/64, and that's the drill that I need. 17/64. Okay, so that's the drill I'll use. I'll fit that, and I'll drill and tap that, and she'll be done. See you soon. Okay, there you have it. I've finished drilling and tapped it, and that's it. All done. And that's basically all that needs to be done to this part now is the black oxide coating that I'm going to put on it. And I don't need to remove that for now. I can just dip it into the solution, and you just sit it in there for about a minute, and that will go from this machined surface to a nice black, as I showed you earlier on that that die holder that I made, and that'll protect it from rusting. It won't matter if that gets clocked. It doesn't add to the thickness of what you oxidize. It just changes the color and gives it a protection on it. So even if it does add anything to the diameter, it'll be very, very, very minimum, 0.01, something like that, 0.02. It won't be anything significant. I don't think it adds anything at all that you can measure, to tell you the truth. It's a chemical reaction, and it basically just burns it to the colour. It just changed. You don't see any smoke or anything like that, but it's yeah, you see it changing before your eyes. It's really amazing. And the key to getting a good finish on that is to really clean this up. So I'll be giving this a good wash. I'll probably give it a quick dip in acid to clean off anything major, like all this oily substance will just dissolve on it. Then I'll give it a bit of a rinse in the degreaser. Actually, I might degrease it first, and then I'll give it a rinse in the acid, and then I'll give it a wipe down with acetone with a clean cloth, and then she'll be ready to be dipped. Okay. Still got the still waiting on the die to make the handle to lock it in, but yeah, that should come in a couple of days, I hope. Until then, I'll see you soon. Bye bye. Okay, here we are. At this point, I've received my M16 die, which, if I remove that, see, got our M16 die in there by 2mm pitch, and we've given this a light machine because this is 16 M16, but it tends to be a bit tight on the dies, so I've taken about 0.1 off it, so we're down about 15.9 thereabouts. It's not that important as long as you don't make it too small. Yeah, and I'm basically going to take thread down to that point there. It doesn't matter if it's longer and sticks out of the mating part, because this has been machined, this step here, to bottom out on the end before this bottoms out on the groove we've machined in the mating part. But I plan to go to about at least to there, so I have plenty of thread, and then once we work out the orientation, then we can work out the bend and where it will end up once it tightens up. So I'll give that a bit of a spray with some cutting fluid. Looks like water, but it's actually cutting fluid. And I use the tailstock on the back of the die itself. I'll just take this out again and explain. Even though this is sitting flat against this face, the reason that this is open, well, one, that you can get it in there for a start, but I like to make it push the tailstock against that face rather than the die holder itself, is because if the die is a little bit, because these are a universal die holder, and these dies are actually made to a tolerance, and look, it's I've come across it where you've got, they say it's 1 inch, and then you say it's 25 mil, and 1 inch isn't quite 25 mil. It's very close, but then you get some that are loose and some that are tight, or just a nice fit. And you can see how, if you look at this close enough, I don't know if you notice it, but you see how this is actually quite a fair big gap, and it's got a very big, where it's tightening down to hold it in there, it's got a large gap at the top and virtually no gap at the bottom. So the die is a lot smaller than the holder, so there is room for movement, and it could kick, you know, in this direction, that direction, that direction, that direction. So if we run off, the idea of pushing with the tailstock is, one, to help get it on started, but it's also to keep it parallel and true to what's in the spindle. But if the die isn't true to the back of here, even though you hold it in there, but when you tighten it up, it moves it. So I always push on there, so it doesn't matter what the die is doing, the holder is doing, sorry, die is still parallel and flat against the tailstock. Okay, we had a little bit of an accident with the camera as I was trying to tighten it up, so I didn't realise I wasn't recording anymore. So as you can see, I'll bring you in for a closer look. I would like to get a few more threads on that. As you can see, the threads were forming. See the spinning in the jaws? I'll buff that out with some emery paper later. But we've got a few threads formed there. I'm going to, before I try to continue, I'm going to see if I have enough to tighten up into the thing. I think I might have enough, so I'll stop the thing, I'll take it out, and I'll go try and screw it into the mating piece. Hopefully I've got enough thread. Okay, we're back, and we're going to see how this threads in. It's actually a nice thread. but having seen how much is in the side there, I think I need a few more threads on it, but to be sure, we'll fit this onto there, and now let's screw this in. And I don't think it's definitely not enough, so I'm going to need a bit more. Alright, well, I'll put that back in the lathe and I'll give it a bit more, and then we'll come back and we'll try it again. Alright, here we go, we're back, and I've threaded it all the way back to where I'd just machined it down a touch, and we should be able to take it up, tighten up now. Now we're actually biting on it and we can't rotate it anymore. So that's basically what I wanted. Actually biting in there quite well, which is what I wanted as well. So the hacksaw cut pattern on the top is doing its job. It does feel grippy, so it's biting into the groove there. Yep. When we remove that, it can still slide nicely on the outer diameter. So there we go. Right, now all we have to do, I might take that little bit of an edge off there. Got a file over here just to get rid of that sharp edge. That's just the point where the die stopped cutting. Okay. Bit of an edge on the front too, but that's better. Nice. Okay. Screw it in there nicely. Doing its job. Take that on. That should go in. It looks like we only needed another thread or two than before, but even though I've made it longer, as you see, it goes all the way in, and we've got more than enough on the inside. But even so, I just want to mark it so I know that's the right angle. When it actually bites. So remove this. And we'll just put an L on that side and an R, so I know which orientation. So it's actually going to bend out towards me. So yes, now we know that. We can undo it. Now I suppose we can get into finishing the surface of this. So I'll start cleaning these up, degreasing them, rub some acetone on them, and then we can get into protecting these from rust. Okay, Van der Grub screw, we'll install it. Tighten it in. And that one goes in a bit deeper, but it's the same effect. That's it. Lock this up. Doesn't turn. Unlock it, and it turns. Yeah, that's all I've got for you for now. I still have to weld that to that base, and I'll bring you back when I'm ready to do that, because I'm not ready to do that at the moment. That's the bluing, even though it doesn't really look much blue on the camera, but compared to the machined surface, now it's just this light, you really can't tell. It doesn't come really dark, it's sort of like a light, like I said, a smoking, but it'll protect it from rusting, and that's the main goal. Alright, I'll leave it at that, and I'll bring you back once I've set up to weld. Catch you soon.